All right, so as you can see here, I'm going to draw a series circuit, and my questions obviously would be a little bit better than this, but for the sake of room, I just have the very bare minimum. 2 resistors and 1 light, one lamp, all in series. So we're always going to start with my battery. My battery is drawn with a long line and a short line, a long line and a short line, plus side and a minus side. I need to connect wires. There's my wire. Now a series circuit, it doesn't matter what comes first. I can put them in any order I want. So I'm going to try and draw 2. I'm going to draw resistor 1. I'm going to draw a light bulb, and I'm going to put the little circle around the light bulb at the end. And then I'm going to draw resistor 2 and connect it to the battery. I need to show that they're connected on both sides. Resistor 1, I could label R1, R2, and that's not my bulb yet. That would actually be okay. Excuse me. But we wanted to put a little circle on it. Now notice there's no switch. Oh no, I forgot a switch. We can cheat. A switch controls the whole circuit. I like to put it near the battery. So I just put a dot and a dot. That shows a closed switch. But if you're doing things in pencil, which I always recommend, you can just do that. Now I have a switch. Now, I also want to add the meters to it. Now, remember, a voltmeter measures potential difference, and that has to measure in 2 different places. The note said it gets added in parallel to the thing we're measuring. So if I wanted to know the potential difference of R2, I would put a voltmeter, a V with a circle, right around that resistor. Notice it touches the wire in 2 different places. The physical meter, I can show them to you. It touches in 2 different places, so it measures the potential difference only there. If I wanted to measure the potential difference of one of these 2 things, I could do it here too. Now notice inside the circuit, outside the circuit, it doesn't matter. Now an ammeter is different. Ammeters measure amps, and in a series circuit, the current never changes. I can put the ammeter anywhere, only one spot. So all I would do is erase a little section, put an A for ammeter, and then put a circle around it. Now, I said I'm going to draw the same circuit a little differently, so I'm going to do it different. I put the battery on top this time. That is a very sloppy drawing. Sorry about that. But resistor 1, resistor 2, and my light bulb. Now again, I'm going to add maybe a voltmeter here. Maybe an ammeter there. And a switch at the top. This voltmeter measures only the potential difference of that resistor. That measures all of my current. And there's my light bulb. Next, we're going to do a parallel circuit. Same thing, 2 resistors and a lamp in parallel. I'll try and draw them 2 different ways. I'm going to start always with my battery. And now parallel are multiple branches. So I'm going to do branch 1. That's 1 resistor. Now I'm going to put the light bulb in the middle just because I want to. And the last one. There we go. Resistor 1, resistor 2, and a light bulb. And I can put my little thing on my light bulb. Now the rules are a little different if you remember. This is a voltmeter. And that voltmeter measures the potential difference of the battery. End of that, because the voltage never changes. The current is different in every branch. This is the trick. Whatever you're measuring the current, you want to put the ammeter right next to it. So I could put the ammeter there. I could put it there. I could put it there. Those three measure the current in branch 1, branch 2, branch 3. If I put one anywhere above this junction, I'm going to put that T there. I made that very big. This would be the total, so we have to be careful with that. Now again, I could draw it a different way. I could put my battery over there. I started with my light bulb. Well, that's okay. Resistor. Resistor. And that's it for drawing circuit. Oh, whoops, sorry. Last thing, I didn't put any switches here. A switch here would control the whole circuit. In parallel, it's a little bit more confusing. I'm going to use this one. If I put a switch up here, this switch turns on and off that, and that, because all of the electricity goes through here. If I put a switch anywhere else, maybe I'll put a switch there. What would that do? Well, electricity always goes through this, but now it can't go through there, and it can't go through there. So be careful when we draw them with switches. I'm sorry, when we put switches in parallel. You are going to have practice on this. I am going to make this 2 different lectures, so even though the last one you watched, I said, I'll be right there. This is going to be a second one, drawing circuits only. That's all. Their last type of circuit is a complex circuit. That is when I put these together with those. But our assignments are going to be as follows. You are going to, there is already a practice up of just Ohm's law and power. The next assignment is going to be practice drawing. Then I'm going to show you how to do all the math involved with all those crazy rules with something that I call a VIRP chart. V-I-R-P, VIRP. I bet you can figure out what VIRP stands for. Okay, that's all I have for you. If you're checking this out on my YouTube channel, even though you're in my class, by all means, feel free to like, comment, and subscribe to the YouTube channel. And that's it. Hopefully, I'll see you all soon. Take care.